All right, let's get one thing straight. Quantum computing sounds like something only Tony Stark could understand. You've probably heard terms like qubits, superposition, and entanglement thrown around, and maybe you nodded along while secretly thinking, what the heck does that even mean? Don't worry, I'm here to explain it in a way that won't make your brain explode, or at least not completely. So first off, what is quantum computing? Well, it's basically the cool older sibling of regular computers. Normal computers, the ones you use to scroll through memes or argue with strangers on Twitter, are based on bits. Bits are simple little things. They can either be a 0 or a 1. That's it. Boring, right? It is like being stuck in a world where everyone has to pick between vanilla and chocolate ice cream, no room for strawberry or pistachio quantum computers. On the other hand, use something called qubits. And these bad boys don't play by the same rules. They can be 0, 1, or wait for it, both at the same time. Yeah, I know it sounds like cheating, but that's just how quantum physics rolls. Spoiler alert, reality gets weird when you zoom in really close. Now here's where things start to get trippy. Remember how I said qubits can be 0 and 1 at the same time? This phenomenon is called superposition. Think of it like Schrödinger's cat, that famous thought experiment where a cat in a box is both alive and dead until someone opens the box. Creepy, right? Qubits work kind of like that. Until you measure them, they exist in multiple states simultaneously. It's like being indecisive about ordering pizza or tacos and somehow having both show up. Except instead of food, it's math. And before you ask, yes, this makes quantum computers incredibly powerful. While a normal computer would have to check every possible solution one by one, a quantum computer can explore many possibilities all at once. Imagine solving a Rubik's Cube instantly instead of twisting it for hours. Sounds nice, doesn't it? But wait, there's more. Another key feature of quantum computing is entanglement. No, it's not some romantic comedy plotline, it's actually a real thing. When two qubits become entangled, their fates are linked, no matter how far apart they are. Change one, and the other reacts instantly, even if it's on the other side of the universe. Einstein famously called this spooky action at a distance. Honestly, though, it's less spooky and more like having an invisible walkie-talkie connecting two best friends. This property lets quantum computers perform calculations faster than you can say light speed. If bits were snail mail, entangled qubits would be instant messaging. Pretty handy, huh? Okay, so why should you care about all this sci-fi mumbo-jumbo? Well, because quantum computing isn't just for nerds in lab coats anymore. Once we figure out how to build reliable quantum machines, they'll revolutionize everything from medicine to cybersecurity. For example, chemists could simulate complex molecules to design new drugs without ever stepping foot in a lab. Hackers might cry themselves to sleep since quantum encryption will make current hacking methods obsolete. Oh, and remember those annoying CAPTCHA tests? Good luck cracking those with a quantum computer watching. It's also great for optimization problems. Ever tried planning a road trip with 6 stops and realized there's no perfect route? A quantum computer could solve that in seconds. Same goes for supply chains, traffic patterns, or figuring out the best way to pack your suitcase. Basically, anything involving lots of variables and options becomes a piece of cake. But hold up, not so fast. Quantum computing isn't ready to take over the world just yet. Scientists are still dealing with some major hurdles. One big problem is something called decoherence. See, qubits are super delicate. Any little disturbance, a stray photon, a sneeze, maybe even a loud thought can mess them up. Keeping qubits stable long enough to do meaningful work is like trying to balance a stack of Jenga blocks during an earthquake. There's also the issue of scalability. Right now, most quantum computers are small-scale prototypes. Building a full-fledged machine capable of running everyday applications is going to take time, money, and probably a lot of coffee. So don't expect to upgrade your laptop to a quantum version anytime soon. Here's a fun fact to blow your mind. Quantum mechanics doesn't just apply to tiny particles like electrons or photons. It applies to everything, even you. Technically speaking, you're in a state of superposition right now. Except your wave function collapses every time someone looks at you. Trippy, right? Don't think too hard about it, or you will end up questioning whether you're real or just part of someone else's simulation. So there you have it. Quantum computing boils down to using qubits, superposition, and entanglement to do things that would take normal computers years, if not centuries, to finish. Sure, it's complicated, but it's also insanely cool. Next time someone mentions quantum computing, you can confidently nod along and say, "Oh yeah, that's the stuff that makes Schrödinger's cat jealous." And hey, if you enjoyed this crash course in quantum weirdness, smash that like button and subscribe for more videos where we explain life's mysteries, because clearly you've got questions and I've got sarcastic answers. Stay curious, folks. Oh, and before I forget, if you ever meet someone who claims they fully understand quantum mechanics, they're lying. Even experts admit it's baffling. Thanks for watching, and remember, science is weird, but that's what makes it awesome.